Hello and welcome to lesson 1 of the second part of the statistics in the year 11 standard course, statistical analysis. The first page that you've got here is just a quick reminder about some of the things that you already know. So in the first part of statistics, we talked about populations, we talked about samples, and we talked about the difference between the two. Make sure if you ask if you're unsure. What we have got that's a little bit new is a couple of symbols that I just want to quickly highlight. So in this paragraph here, it just says when we find the mean of a population, we use the symbol. This symbol is called mu. So here, mu is the mean of a population. The mean of a sample has got a separate symbol, this one here, which we call x bar. So mu x bar, you hear us say one of those funny things, that's what it means. Secondly, standard deviation. We'll come to how you calculate standard deviation, what it is later. When it's the standard deviation of a population, it's got this symbol, which is sigma, and the standard deviation of a sample has got the less symbol s, and it's just an italic s, and it matches what's on a Casio calculator, which is really useful as well. As it says below, we'll consider how we work these out. This is just a quick introduction with notation. On the second slide, we are looking at what are called measures of central tendency. You may also have heard that as measures of location. What are measures of central tendency, measures of location? Well, they're just ways of calculating where is a lot of the data clustered about. What are kind of the general areas where we're going to find most of the data. The types of measures of central tendency, you all know, you've heard before, it's mean, median, and mode. I'm going to assume that you can calculate the mean from a list of numbers. If you're not sure about that, then make sure you get some revision on that by asking in class. What instead we're going to do is have a look at working out the mean age when we have got a grouped frequency table. So this grouped frequency table has got some people put into groups. Here it's ages, teachers of school, so 20 to 29, 30 to 39, 40 to 49, and so on. Class centre I'll come to in a second. The frequency, the third column, just says how many people at the school are in the age bracket on the left. There are 5 people in the age bracket 20 to 29, 6 and 30 to 39, and so on. So how do we calculate the mean? Well, technically, actually, we're going to calculate an estimate of the mean because these 5 people, we don't know exactly how old they are. We just know that they are somewhere between the age of 20 and 29. So what do we do to calculate the estimate of the mean? Well, we just assume that everyone's in the middle of this age bracket. And if we assume that everyone's in the middle, some will be above, some will be below, but hopefully it'll even out. So the way we write that is we use the class center. How do we calculate the class center? We add the two ends, so 20 plus 29, and then we divide it by 2. So how do you find the middle of anything? Well, just add them together and then halve it. It's just as simple as that. So that is 24.5. Do the same things with the other one. 30 plus 39 over 2 is 34.5, and hopefully you can quickly realize that they're just going to go up by 10 each time because the class brackets are going up by 10 each time. So we've got 34.5, 44.5, 54.5, and 64.5. So the class center, we give this symbol x to say that's a variable to represent all the different pieces of data. F is the frequency, how often they occur, and this final column, f times x, asks us to multiply those two together. Why? Well, in the first row, what that's saying is there are 5 people in the age of 20 to 29. If we assume that they're all that middle age of 24.5, it's 5 lots of people who are 24.5 years old, so we can find the total of all those 5 people's ages. You'll need a calculator to do this. I've done it first, but it's 122.5 If you then do 6 times 34.5 for the second one, you will get 207. 8 multiplied by 44.5 gives 356. The next one, 763. And finally, 193.5. The totals, so these bottom two spaces, bottom two cells, add up the totals. So they add up all the numbers in the column above. So the total of 5, 6, 8, 14 and 3 is 36. And the total of all the numbers in the F by X column is 1,642. So what's our estimate of the sample mean age of all teachers in schools? Well, we're using a sample. We don't have the entire population of all the ages of teachers in schools. So our sample mean, bar X, is equal to the total of the FX column. So the total age of all the teachers in the schools divided by the total of the F column, so divided by how many people there are. Once again, we put that into a calculator, you will get 45.6 accurate to 1 decimal place. That's it, mean from a grouped frequency table. Mean from a frequency table is very similar. However, you won't have groups or class centers. You will just have some quantity that's been measured. So the ages, or in this case, perhaps you might have something like number of goals scored, might just go something like 0, 1, 2, 3, and that's what you'll multiply by the frequency. Again, you can ask for help on that if you're unsure. The page after this is about the median. The median is the thing in the middle, so the piece of data in the middle. Once again, it's a measure of location because we think, well, most of the pieces of data perhaps will be around about the middle. So the example here says a maths department recorded the number of interviews that its teachers had on a parent-teacher night. The number of interviews were 14, 18, 13, 9, 21, 16 and 16 again. What was the median number of interviews? Well, first step whenever you have got to find the median from a list is you need to put the list in numerical order. So what I would tend to do with this one is cross off the numbers as I go, just to make sure I don't miss any out. Look for the lowest number to start with, that is 9. Cross it out. What's the next one? 13. Cross it out. We've got 14, 16, another 16, an 18, and a 21. How do we know which number to pick when we're looking for the median? Well, the simplest way is we just think about which one's halfway by adding 1 to the total number of pieces of data in the list, which is 7, and then halving it. So the piece of data that's in the middle will be halfway between the first piece of data and the last piece of data. 1 plus 7 over 2 is the fourth piece of data. So the fourth piece of data in this list, the first one is 9, 13 is the second, third, and the fourth piece is 16. So the median is equal to 16. You should notice that if you put your finger over the 16 and cover it up, on either side of the number that you've covered up, the 16, there are equal sized lists. So there are 2 lists of 3. Some people prefer to do it this way, sort of by sight. So what number do you need to put your finger over in order to make sure you've got an equal list on either side? It doesn't quite work with even numbers, of course, and we'll come back to that later. So if you've got even amount of numbers in the list. What's the modal number of interviews? The modal number, the mode is the one that appears most. There's only one that appears more than once, and that's 16. So the mode is 16. If there are two or more numbers that are tied for an equal amount of high appearances, so if we had an extra 18 in this list, for example, both the numbers would be the mode. So you can have more than one mode. You can never have more than one median or one mean. The last thing we're doing is the median from a frequency table. Median from a frequency table is a little bit harder than just medians from a list, so that's why I've given it just an extra slide. So I went on imdb.com, the Internet Movie Database, had a look at the ratings of episodes for the original series of Star Trek, and then I rounded those to the nearest whole number. The rating out of 10s come as follows. So there's one episode that was rated a 5, 7 episodes that were rated a 6, 31 episodes were rated a 7, so on and so on. How do we figure out the median? Well, first off, what we need to know is what is the total number of episodes that were rated? So how many episodes are there? If we add up 1 plus the 7 plus the 31 plus the 30 plus the 10, you will find that there are 79 episodes in total. How do we figure out the median? Well, as before, we need to know in which position does the median lie. So the position of the median is that it's halfway between the first and the last piece of data. So the position of the first piece has got a value of 1. The position of the last piece of data is position 79. Add those two, and then divide by 2, you get 80 divided by 2, which is 40. So the median piece of data is in the 40th position. How do we find the 40th position? Well, we just keep adding up the frequencies until we get to 40 or a number that's above it. So in blue on the right, I'm just going to do a little running total of the frequencies, also called a cumulative frequency. So for a rating of 5, there's just one episode included. For a rating of 5 or 6, there's 1 plus 7, so a cumulative frequency of 8. For 5, 6 or 7, it's 1, 7 or 31, so 39. Not quite at 40. Once we add on the 30 episodes that were rated an 8, we get up to 69, so we've passed the 40th position. So if we passed the 40th position while we were looking at episodes with a rating of 8, it must mean that the median is 8. Easy peasy. What's the mode? Nice to find from a frequency table. You just look for what frequency is the highest, and then the mode is the score associated with that frequency. So the highest frequency was 31. The score associated with that frequency of 31 is 7. So the mode equals 7. Okay, as it says, you should now be attempting exercise 10A. As before, have a look at the questions suggested on the inside of the workbook and pick the level that's appropriate for you.